Okay, I'm going to go through this pretty quickly because we've done these in class and that type of thing before. But remember, when you're combining a carboxylic acid and an amine, you make an amide. So I'm going to take this OH and one of these hydrogen and make water, which means that this nitrogen would translate just like this. And you'd end up with water. When you separate things, we've got a base hydrolysis here. Even though it's not drawn in, you have water present. So just know that, okay? And I'm going to get a carboxylic acid and an amine, just like that. Now, I drew those out without taking into account that we're in base. So now let's take into account that we're in base and erase this hydrogen entirely, because in truth, that negative charge is going to be there. Why? Because this OH minus will remove it. Okay. So let's just keep going with that. I'm going to break this bond right here, and in doing so, I end up with a carboxylic acid that's here. Oh, that was not good drawing, sorry. OH plus, I've got an NH, boom, boom, boom. Now this H isn't drawn in there, but it's totally there already, right? But we're now in acid, so we need to take that into account and erase those lone pair of electrons and instead put in an H with a positive charge. Good job. So next we're going to go and do the same thing right down here and separate our reactants, or separate our products, rather, into our carboxylic acid and our nitrogen-containing compound. We're also going to put on the hydrogen. Keep in mind that this OH and this H are the water that you're adding right there. So if we keep in context that we've got an HCl that's there, that means that we've got an acid, and an acid will react with our amine, giving us a positive charge right there. Okay, let me scroll on up. Oh, we got a few left, huh? Okay. So next we're going to do a reaction with just base. And so again, we take this bond and we're going to break it. And also end up within, there's two hydrogens there already, and there's the third. Now, we got to take into account that we're dealing with an NaOH, and since we are, this hydrogen is gone, and we're going to instead end up with a negative charge. Now, again, water is not written in there. You should assume that water is there. Okay, water has to be there. It's just a solvent. And a lot of times we don't write solvents in. Okay, the next problem, number 6, actually what you're doing here is you've already got the carboxylic acid and the amine. So you're actually just making the amide here. So we're going to combine those guys and you end up with that. And if you want to write plus H2O, that's fine. Same thing. Okay, number 7. This is the bond that we're going to break. And you end up with this plus your NH3 in this case. Now, we have to keep in mind that we are in acid. So since we're in acid, we need to add a hydrogen right up here on our nitrogen. You may need to slow this back down and do all these for yourself. That is okay. Okay, I'm going to blow this up so we have more room here. Again, we're going to separate this bond right here. So I'm going to go ahead and do that. That little circle inside, don't worry about that. We'll talk about that later. It just means those double bonds that we've seen before. We've got one hydrogen and one hydrogen. So I separated them first and then realized that we are in base. So since we're in base, we have to erase this hydrogen right here, and instead we will have a negative charge. And finally, this is the bond that we're going to break again. We end up with our carboxylic acid and our amine. Okay, well, let me do that backwards because I don't want to mess you up with that. It doesn't matter to me, but if it does to you, I don't want to mess you up with that. And then keep in mind that we're in a base, so I'm going to erase that hydrogen again and give you a negative charge right there. Again, these two problems do not list water. You should assume that water is available to you to make those reactions happen. I hope that helps. We'll see you soon.